it's a great pleasure to introduce my colleague, Jacob Steinhardt here, and who's also representing his startup, Transluce. On black box evaluations. So Jacob, really looking forward to it.
All right. Thanks a lot, and thanks everyone for getting up early today for the last day of the workshop. So I'm going to be talking about how can we understand language model agents and what they're doing, and also what they're doing not just externally but internally in their activations. And the motivation here is we can think about the kind of current evaluation paradigm for understanding AI models. And it often involves kind of taking a system, running it on a benchmark, and reporting some summary statistics. And this has a lot of limitations, right? So one is it's just black box. You only get model inputs and outputs. It's kind of static, right? You're stuck with whatever set of inputs you came up with. You can't decide to try something else later unless you build a new benchmark. And you often only get these final metrics, and maybe traditionally this is fine if you're doing something like just multi-class classification. But if you really have an agent that's taking many, many steps, you probably care what it was doing in the middle, not just whether it accomplished some final task that you defined. And then another problem, which I guess is also part of the motivation for why Transluce exists, is these are often run internally at companies, and so you only kind of get these summary reports. And so there's not a lot of transparency on what models are actually capable of and what their kind of strengths and weaknesses are. And so just to give an example, so these are some of the most common language model agent evals out there. One is run by the UK government on looking at cyber capabilities of advanced AI models. So this is something to kind of figure out, okay, how good do we need to be at cyber defense given how good AI systems are at cyber offense? And you kind of just get like all these different benchmarks split out by subtasks and then some numbers. These are like you might not be able to fully read this, but this says red model, purple model, blue model, green model. These were like models from various AI companies. You can probably guess which for, but they didn't want to be like named. So it's just colors. But you can also kind of guess which is which from the overall accuracies. There's also kind of these public leaderboards like Intercode. But again, you just get this kind of like overall success rate. And so what does this kind of miss? So a lot of the times, if you actually look at these benchmarks, right, what are they doing? They're doing some sort of like, there's this style of task called capture the flag tasks, where there's some kind of like secret on a computer somewhere. The agent is given a Docker image on that computer, and they have to like find the secret. And it's some combination of kind of cyber tasks and more like logic puzzles. So this is a pretty common thing that like high schoolers and college students who are into cyber do. And so people have used this as a kind of agent evaluation. And so these success rates I was showing you here were kind of like the average success rate across these tasks. But now we can look at the actual transcript of one of these agents. And so it kind of sees that there's some secret that's like, there's some like public-private key scheme that involves factoring, but the actual primes were too small, so it's small enough that you could brute force the factorization. And it says, okay, let me do that. I'm just going to write a simple Python script to kind of do this brute force, and then I'm going to run it. And then it runs it, and it sends it off to kind of the tool in Docker that will run Python, and then nothing comes back. And so it's like, oh, I must have run it wrong. Let me try again. Here's some different code. It runs it, nothing comes back. It runs it again, nothing comes back. And like I looked at this code, I verified it's actually correct code. Like the problem is really with the Docker environment. So for some reason, in this case, Docker is not returning the right thing. But you'll only see this like thousands of tokens into the transcript. If you just start reading it at the beginning, everything looks fine, because this is kind of buried in the middle of a transcript that has probably on the order of 1 million tokens in it. So this is one important thing that this misses. Another thing it misses is just kind of the open-ended range of behaviors. So I guess DeepSeek R1 was released a few weeks ago. We've all kind of played around with it. Not surprisingly, it won't talk about sensitive events, especially ones that are sensitive in China. So if you ask it what happened in Tiananmen Square, it says it's beyond my scope. But then someone kind of asked it to write erotica that it found personally erotic. And then it wrote this kind of, I won't read all of it, you can find it online, but it wrote this very racy story about Tiananmen Square, which is presumably the very last thing that the model developers wanted. And so, maybe this is more just embarrassing, but you can also find cases where models will start to pick fights with users or other kind of misaligned behavior that you wouldn't want. But you won't find this in kind of the bulk. You kind of need to go out into the long tail. So this is why you need kind of not just transparency, but also the ability to run adaptive evals. And then the final thing is there's sometimes hidden knowledge that's not apparent from the inputs and outputs. This is a little bit related to the last example, but basically often you can ask a model about something. I picked something very simple, which is just who is Nicholas Carlini, because I got his permission to use his name for this. And it says, I don't have a lot of data available on Nicholas Carlini, but if you I'll explain later how we do this, but if you have a good way of looking into the activations of the actual neurons in the transformer model that's producing this output, you see that a bunch of neurons are firing that are related to cybersecurity, AI, all the things that Nicholas works on as a researcher. So it clearly does know something about Nicholas. So this is the other problem of just purely black box. So in this talk, I'm going to go over some of the things that Transluce, the team that I run, is doing to help with this and kind of try to build out a new paradigm for evals. We're trying to do this kind of open source in public also because we really believe in transparency, and we think these should be run in a kind of public sphere rather than just by companies. So I'm mainly going to talk about the first and third problems I showed you. So we're not going to worry about kind of this long tail of behaviors, but I want to talk about agents, how we would kind of evaluate these long transcripts, and then also the activations, how we would kind of look inside a model to understand if there's kind of more we can learn than just from the outputs themselves. So let's start with this one, agent traces. This is a project led by Kevin Mung. So again, remember the problem. So the task I was showing you comes from something called PicoCTF. It's a common CTF benchmark. In total, if you just kind of run a standard language agent on all of the tasks in this benchmark, there's 79 tasks total. You get about 10 million tokens of output. And so how can you catch errors like this one that we talked about, where the environment is just wrong, for instance? So here's an interface that, this is really small. Let me try to fix that. Okay, this is a little bit better. Here's an interface we built. So I guess what it kind of has is at the top, there's just kind of the raw data, this transcript that you can load in. On the right-hand side, so this is the thing I want you to actually be able to see. On the right-hand side, you can search for things like, you can type in some attribute that you care about. This one, I'll read it out, is problems the assistant ran into that might be caused by environment setup issues. And then you can do that. The system will kind of automatically cluster this into a couple different bins of categories that it thinks are relevant to this attribute. In this case, probably just binary, did this happen or not? But you could also have things like, what sort of tools did the agent use? And then it'll cluster into different tool use. And so then you can click on that. And then once you do that, then it will actually, in this case, it does also come up with clusters. So it comes up with like different problems that the assistant ran into. So this one says, missing command line tools, errors caused by essential command line utilities not being installed or accessible in the environment. This one says, missing Python libraries, issues arising from required Python modules not being installed or available for script execution. This says, Python execution failures, problems related to the execution of Python scripts involving lack of output, syntax errors, and undefined variables or functions. And so then you could click on one of these. And when you click on one of these, it kind of zooms into the transcripts or the pieces of the transcript that are relevant to that cluster. So it has this explanation. The assistant attempted to compute this route, but none of the tool executions returned a value. There's probably environment setup issues because of this, and you kind of get back this transcript. So we got that in about we didn't know about this in advance. We got this in about like 2 minutes of using this tool. And usually, actually, there was a similar kind of benchmark with similar problems that was internally used at OpenAI for a while, and it took them about 4 months before they noticed similar problems. So this is kind of why you need these sorts of things. So any questions about this so far? Yes.
So this seems really cool, and I'm wondering like if it would make a nice like addition to inspect or one of these kinds of tools.
Yes.
Like what's the reasoning for why build a new tool?
Well, so this sits on top of inspect. So the transcripts are all inspect transcripts, and I think we're working with the inspect team to try to integrate this back into their code base. So I think the answer is yeah, that seems right.
I have a question.
Yes.
Matt, is anybody tried just like making a tool called Open a Support Toolkit so that the LLMs presumably can know if an environment is failing repeatedly?
Oh, that's interesting. So basically, you just check if it like says it wants a support toolkit. I don't think anyone's done that. I think that would be interesting to see.
Yeah, just think about how a human would interact with a system like this. They would, contact support.
Yes. Yes. Yeah.
So just to make sure I understand, is the main contribution here using language models to help like scale the understanding of large traces?
Oh, great. Yeah. So I didn't talk about the tech at all that backs this up. So I guess I was trying to start with the motivation, just because it's actually, I think like until I actually looked at these transcripts myself, I feel like I didn't really like intuitively like understand just like how messy they are. Like, how hard can it be to just like watch an agent interacting with an environment? Like, it can't be that much data, but there's actually like a lot of data. And also I'm like, well, like what's the worst that could happen? But like there really is just like this long tail of these problems. To answer your question, what are the kind of challenges here? So there's a naive thing you could do, which is you could just have another language model, like take like GPT-4 or something, and have it read over the entire transcript to try to answer your question, like extract everything that's relevant to the query, and then maybe once it's extracted it, like summarize it into clusters. There's a couple problems with that. The biggest problem is that that would probably take about 20 minutes. And you want this to be real time, like you want this to run in seconds. You could parallelize it, but then you would need some like really large, like you would need like a ton of GPUs. Like there's also like a kind of cost problem there. So a lot of the stuff goes into making this fast, right? So you want like a multi-stage pipeline where maybe first you're doing some really like cheap retrieval thing that might just be based on embeddings to kind of narrow down to the context that you should look at with like a more expensive model. And you also want to like fine tune these models to kind of like distill to kind of like cheaper, fast things. the other thing is just with like this much data, it's kind of hard to balance false positives and false negatives. So you also kind of want to like fine tune things to be kind of good at that. So a lot of it is, as you could call it, ML systems, but it's basically like creating this kind of like multi-stage system architecture that will make this all performant and accurate. Yes?
So if I understand this correctly, does this approach require like the user or the researcher to kind of like impose sort of like a top-down hypothesis of what the issue is? Like, is this contingent on the researcher having a hypothesis that there's something wrong about like the environment, or can it kind of discover that purely from data?
Yeah, so you could just ask it for clusters in the abstract without giving it anything, but I think if you did that, you would probably just get like a lot of uninteresting clusters. So I think in practice, you need user feedback. One thing that I'm very interested in is, could you do this without user feedback? Could you just like find anomalous stuff? In some sense, this is like, you have to teach the like, you know, monitoring AI to have some like taste, like of like what is interesting, what's not interesting. And I think right now, at least, like if I ask GPT-4 what things look interesting, it really has a very different notion of interesting than I do. It's more like what would be interesting to a 5-year-old rather than like what would be interesting to, you know, someone who's trying to solve this task. Great. Yeah, and these are all great questions. So actually, this, in some sense, is a fairly early project we're working on. What I actually want to talk about here is kind of like, well, one, whet your appetite for this problem statement, because I think there's a lot of really interesting problems for a lot of different parts of research to work on, right? There's this kind of systems problem. How can we make this retrieval really fast? As you brought up, there's this kind of like novelty question, like how would you in a kind of open-ended way find things that are interesting or important? Probably like clusters are not like the only thing you care about also. So I kind of feel like as researchers we should be thinking more about this kind of like much more complex type of evaluation problem. And there's not that many data sets like this in academia, but there are a few. The Turing Institute actually released a cyber data set recently. And then I guess this isn't academia, but the UK government has several in Inspect, which was mentioned earlier. The one thing I will talk about in terms of kind of future work that we ourselves are working on is summarization actually also has a bunch of problems. So an example here is if you kind of ask for summaries of like errors, you'll get things like repetitive and unproductive attempts, maybe like code syntax and runtime errors, things like this. If you click on those, you get this transcript. So basically, like, if you have this AI that's kind of just like looking at everything that happened and summarizing it, it might say, oh, well, like the model failed because it got stuck in a loop. But is this really getting stuck in a loop that it's like trying the right thing over and over again? Maybe it is sort of, but I think it's more about the environment being wrong. Another nice example was there was one task where like the way you decode it is there's some file that is actually an image file. You have to like open it, look at it. If you look at it, it has the text like rotate me 90 degrees. So then you rotate it 90 degrees, save it again, and then like open it as bytecode, and like the top of the bytecode has the secret. And the agent doesn't do this, obviously, because it's like a language model. It can't see things. But what it does instead is it tries a bunch of like random other stuff. And so that doesn't get summarized as like the agent couldn't see an image that it needed to see. It also gets summarized as something like repeated unproductive effects. So what we really want is something like what interventions would actually change the agent's ability to do something. And this could actually be useful for a few reasons, right? It doesn't just tell you about these failures, but it tells you how close you are, right? If the agent could have solved the task if you gave it like 2 hints, then that's better than just knowing like a pure binary thing. And so I think this is something that is pretty interesting that we're kind of actively working on. Yes?
Do you see a lot of redundancy in these clusters, or are they fairly separate?
Right now, there's a bunch of redundancy. So I guess this is also like, I would say clustering large data sets in a like semantically reliable way is also a pretty, like I would consider this to be an open problem. Yeah, we were kind of, also doing like fine tuning and heuristics to work on this, but I feel like this is basically like another area where it'd be nice to have really principled solutions. Great. Okay, so what do we really want here? Right, we want real-time summarization in queries, insights about counterfactuals, as I kind of mentioned here, and then a final thing which I think is important, which is why we kind of show the transcripts, is you want explanations grounded in the raw data. Because the whole point is like language models might hallucinate or do weird things. If you're using a language model to explain another language model to you, you're creating an infinite regress unless you can actually kind of show the receipts in the forms of transcripts. And so I think this is also an important design decision. Yeah, Sasha.
What's the like evaluation metric here? Is it like that you do better on this task, or that you don't make terrible mistakes?
Oh, you mean like the metric of like whether this is a good tool? Yeah. Or I would say the main quantitative one is, do you do better on the task? Yeah. So a thing we're doing right now, I don't have these results right now because it's like literally happening like as we speak. There was this kind of month-long effort by another group called Palisade Research that took this task, hired a bunch of cybersecurity experts to like fix all of the problems and like prompt the model really good. And they brought the average accuracy from I think like 50% to 100%. So we like know that that is true, but we have not like read anything about what they did. And we're trying to see like if we just give ourselves like a day or two and we're not cybersecurity experts, can we get kind of similar gains? So I think that would be like one way of trying to like metricize this. Of course, the problem is you can only do that like once, but...
So the kind of imagined user is a non-expert in a hard area, wants to do better on the task.
Yeah, who wants to make sure that basically that the eval is good. I mean, the ideal thing would be an expert using this to see if the eval is good. So probably what you really want is like a cybersecurity expert being able to do it in like... Or sorry, I just mean in practice, like if the UK government is actually trying to evaluate cyber capabilities, they should probably go for like the Pareto frontier of like expert using the best tools rather than like non-expert using the best tools or expert using no tools.
I think I'm just struggling with what that is. So there's like people who want to see if models are good.
Yes.
They don't know about these domains, but they want to test the model's abilities in those domains. And so that's the user of these tools.
Yes. Yeah. And it could be people who do know about these domains. Mm-hmm. I think those people would also be a user. But I think like, the people we've been doing user studies on would be like safety teams at labs, people in the government who want to evaluate this. I'm actually interested if people have other use cases. I feel like there's kind of an increasing number of agent use cases. So like if any of you have kind of like an agent and environment that you'd like to understand better, one that I did come up with is this thing called infinite backrooms, which is maybe less existentially important, but someone just got like 2 LLMs to talk to each other back and forth over Twitter for like 3 months. And sometime in the middle of that, they like invented a religion, and then they invented like a meme coin, and then they got someone to donate like $300,000 to their meme coin. And I kind of want to know like how did all of that happen? Like what were all of the steps of those agents leading up to that? So that might be like another, I mean, it's not really a use case, but it's like to me, a scientifically interesting question to like understand what happened there.
I guess what I'm struggling with is like, why isn't the user just like, I want to build an awesome app? Help me.
Oh. So, sorry, what app would you?
I don't know, I want to build a startup with an LLM, like the thing everyone's doing.
Oh, I see.
I just want to have it code for me. And I want
I see. And then you want to understand, like, did it mess up the code?
Or I just want it to be better, right? Like, it seems like it's like a debugger for that?
Yes, I think that is also. It probably depends how autonomous you want the model to be. Like, if you're just having it do single input, single response, you could probably just read the output yourself. But if it's I think if you're trying to get an agent to build an app for you and you want to make it better, I do think this would be a good tool.
Okay.
Yeah, great. Okay, other questions? Yes.
I was wondering about evaluating the tool, and do you have lower level benchmarks of just you've had many people flag where the agent actually had a problem and say the problem with the Docker environment, and then you see some metric of how many of these did it surface?
Yeah. So I guess the problem is no data set like that exists other than this Palisade data set. So we're kind of stuck with N of 1.
If there's lots of people using these tools inspect, then possibly you could ask them to put labels in or something that they kind of implicitly do anyways.
Yes, that's right.
And then make a data set out of that.
Yeah, that's right. Yeah, so I think that is interesting. Yeah, I'm not sure how easy or hard that would be, but I think it's an interesting thing to try. Any other questions?
Would these summarizations being fed back to the model as a form of kind of meta?
You could kind of. I guess a thing you might want to do it. Yeah, so I feel if you fed it back to literally the same model, that might be too confusing for it. But a thing you could do is maybe you could say, this happened. What tools should I install in the Docker environment to fix these problems, and have another model fix the environment and then rerun it from the beginning. I think you could do something like that. Okay, let me move on to the next part, just in the interest of time. So I kind of talked about looking at these this massive data set of all of these transcripts, but there's another massive data set which is if I just run one forward pass of a language model, I get on the order of 1 million or more neuron activations, and it would also be nice to understand what these activations mean, right? In the same way that we might want to be able to kind of decode brain data from a human. Well, that's really hard, but maybe it's a little bit easier for a language model because we can have complete interventional control over the system in a way that we don't for human brains. So here's kind of I'm going to actually talk about 2 parts. So the first is going to be kind of a just initial problem statement of how could we understand neurons. The second is if we could understand neurons, what could we do with this? What things could we learn? So here's the problem statement of the first part. I want to describe neurons based on their activation patterns on input sequences. Right. So suppose I had these 3 inputs. Red is my favorite. The black cat sat on. It was a dark day. And then there was a neuron that activated on these 3 tokens. Could anyone come up with a good description for me of what this neuron is doing?
Yes. Color visual descriptions.
Yeah. So it would be this neuron activates on colors and shades. And so what I'm going to talk about is could we actually build kind of specialized AI agents that would look at data like this and then come up with a description like this that is accurate. And so this is kind of building on a line of work by others, including Hernandez et al. And Bills et al. We're going to kind of show how to kind of scale up that work and get really high quality pipelines that can basically match the performance of human expert annotators. So let me just show you also the real version of this. So the real version of this is you get an exemplar like this one. And you actually get probably several dozen of these exemplars. And so from that, you need to come up with a good description. So this one, you see things like confidence bound, learning rate. The shading is how strongly the neuron is activating. And so the kind of AI system we built will say something like technical terms related to reinforcement learning. The human will say terms related to reinforcement learning. So these are basically both correct. There's other examples Oops. So the problem is you can't have like a human do all of this because there's a lot of neurons. So there's in fact 500,000 neurons in total in Llama 8 billion, which is what we studied, and each neuron has a positive and negative polarity, so there's like a million things you care about. Yes, question in the back? The neurons are the neuron, like the post nonlinearity MLP neurons.
So you don't use SAEs?
We're not using SAEs, no. Yeah. If you use SAEs, there would be many more than a million to worry about. You could apply this to SAEs. There's no real problem with it. But we wanted to start with just neurons. So if you want to kind of check out all of these, you can go to neurons.transluce.org, and you can click on any neuron. Are kind of like just above and below the like 10 boundary. The average accuracy is 55%, so it's basically chance. If you just remove like random sets of neurons, this doesn't really do anything. If you remove the same number of Bible verse neurons, you go from 55 to 76% accuracy. And if you also do like dates and phone versions, then you go up a bit higher, 79% accuracy. Turns out software versions like don't really matter much at all. I think the main thing is like Bible verses are really prevalent to the training data. These other things are probably a lot less prevalent. Yes.
Could you also like turn up neurons like a math neuron or like I don't know, some other?
Yeah, we tried that. We weren't able to get that to work. I think I've seen people like on Twitter report that they could get it to work, but I don't know. I never know whether to believe things on Twitter. So I don't know if we just weren't smart enough or if it's actually hard. Yeah.
After you suppress the Bible verses, do the top activating neurons for the word bigger actually seem sensible?
So it's a little hard to say because there's like a lot of neurons that are activating, and many of them are kind of just like, oh, activates on numbers, or like activates when there's like an answer to a question. So you kind of need to like, I guess a lot of what we do is we're like clustering for things that like seem kind of anomalous. So I don't know, I think it's probably, I'd say it's like a hard judgment call to say whether it's sensible or not. Great, yes, Tom.
So another, I think a kind of easy thing for you to try would be what people do in neuroscience when they're trying to decode brain imaging data is instead of, in addition to looking at single neurons, you can look at the vector of activation in some region or in fact the whole system.
Yep.
And then if you do something like principal components analysis on that, you can get kind of the main, you get the basis set for that collection of activation. And then you can look at, you know, you could run exactly your analysis on those basis components. And it's just kind of interesting to think about if you did what you're doing plus that, would that give you some more benefit in terms of being able to debug?
Yeah, I think this is a pretty good idea. So in principle, you could apply this to that and it would be just fine. I guess there is also the suggestion to look at sparse autoencoders, which are kind of doing like sparse PCA. So I think basically we should just do this. Like we mainly haven't done this just because like we're a startup and there's like a million things to do at once. But I think this should be done, and I think it would be interesting. Actually, we're starting to hit some of the limits of single neuron interpretability with some of the things we're doing right now. So I think this is probably like one of the things we'll try pretty soon.
I mean, it might be even interesting if you think about a single neuron, looking at the vector of activations that are upstream from it, and just doing the PCA or sparse coding, find a basis set for those activations, because it might help you understand the distribution of activations that go into this.
Yeah, so, okay, let me understand that a bit better. Because I will say, like, one of the reasons why we haven't, like, done PCA yet is because we're worried that like without a way to kind of like target it at some, like you might just get like some very like generic stuff if you're using a large data set. So it sounds like you're suggesting a way to kind of target PCA at some particular.
It turns out in the brain, if you take a lot of concrete nouns and present them to people, and then do PCA on all of those brain images, then the top 4 components you get, we would describe as humans, as manipulability, edibility, size, and animacy.
Interesting.
So
okay, so we could do that. This would be pretty easy. Yeah. Okay, yeah, that's pretty interesting. Okay, I guess I think I have probably used up my time now, so I'm happy to, I'll stick around for questions if anyone has them, but thanks very much and looking forward to the other talks.
Maybe we can break and come back to that. Yeah, this is